Welcome to the segment of Understanding Mathematics with Engineer Stanslous Mbala. And I know this segment of mathematics is going to enlarge your understanding and give you the capacity to be able to handle mathematics. So today we are continuing on the same segment of transformation, and this is nothing other than enlargement. Last time we did reflection and rotation, and we are hearing a lot of testimonies and a lot of feedback how children are enjoying mathematics, and many of them they are scoring distinctions. Oh, what a powerful testimony. So please follow us again. We are just about to start the next segment of enlargement. So enjoy and make sure you are always up to date with mathematics. Thank you so much. Follow us on Facebook. It's just Epignosis Seed of Destiny. Epignosis Seed of Destiny on Facebook. And very soon we'll be opening our YouTube account where you can follow our video tutorials of mathematics and science. Nothing else, it's maths and science. Zambia shall be transformed by the spirit of mathematics and science. Thank you so much. This is our third segment of transformation. We did reflection and we did rotation. So today we are doing enlargement. So this is our topic today, enlargement. Right, enlargement. Before we can talk about enlargement mathematically, first of all, we want to explain to you to enlarge simply means to increase the size of something. That is what it means to enlarge. So whenever you are increasing the size of something, it means you are enlarging. Now, mathematically, we need to know what enlargement is. Mathematically, we can say this is when the object and image have same ratio. When the object and the image are proportional or have same ratio, that is what is called enlargement. For example, I can say, e.g., you've got this smaller triangle and you've got also this bigger triangle. If you look at these all triangles, they look the same. They are all 90-degree triangle. Let's say this is 4 and then this is 8. Let's say this is 3 and this is 6. Let's say this is 5 and that is what? 10. Now, I want you to follow me carefully. This side here, if this is the object and that is the image, so we can say we have enlarged this object to produce this image. So this side here corresponds to that side. This side here corresponds to that side, and this side here corresponds to that side. Meaning, if you say object over the corresponding side image will give us what? 4 there 1, 4 there 2 half. Not only that, also if you say this object 5 over the corresponding to the image which is 10, it also give us 5 there 1, 5 there 2. You also say this object 3 out of 6 because this side corresponds to that side. So 3 there 1, 3 into 6, 2. So you can see they both have the same ratio. A ratio as half, half, half. Since they both have the same ratio, it means this is enlargement. So we can say triangle O, which is the object, is similar to triangle I, this one. So triangle O and triangle I are similar. Why? They have got the same ratio. So this is enlargement. Now, I want you to remember that the factor we use to enlarge, the factor we use to enlarge the object, is called scale factor. And it is represented by K. So that factor that we are using to enlarge this object to produce that image is what we call the scale factor. Now this is the formula for the scale factor. Scale factor K is given by the formula: the distance of image over the distance of object. So distance moved by image over distance moved by the object, it will give you the scale factor. So we can say scale factor equals to, look at it, it's up to you. You can either pick this as an object, that as an image, this as the object, that as an image, this as an object, that as an image. So if I pick my object to be this one and my image to be this one, so it will be 8 as my image, my object is 4 over 4. So the scale factor is 2. So it means 2 is a factor that we are multiplying to this object to enlarge this image. So 2 by 3, 6 enlarged. 2 by 4, 8 enlarged. 2 by 5, 10 enlarged. So this is how you calculate the scale factor. Now, there is something I want you to understand about the scale factor. Very, very, very important. Don't forget this, guys. It's important to remember this. So, rules to remember. Since you already know how to find the scale factor, now there are rules you must remember. The first rule is this one. Rule number 1. When the center of enlargement is between object and image, scale factor become negative, meaning your answer should be negative after calculating. A good example is this one. Let's say we have this as the object, the way I gave it to you, 3, 4, and 5. This one is the object, and it was enlarged by that. This is the image. As you can see, this was 6, this was 8, and that was 10. So when they ask you in the exam to find the center of enlargement, it's not difficult. Just have to join corresponding points of object and image. For example, this point of the object corresponds to that point of the image. You take your ruler, you join with your ruler. Also, this one has been switched down. It means this point of the object corresponds to this point of the image. You also join them with a ruler. Where they meet, that is the center of enlargement. It's simple. So, enlargement now, the scale factor will be distance moved by the image over distance moved by the object, which will be equal to distance moved by the image. If I take 6, it has to be over the corresponding side, 3. So the answer is 2. If you write 2, I'll mark you wrong. So the scale factor is negative 2. Why? Because the center is between the object and the image. That's the first rule on scale factor. We go on rule number 2. Rule number 2 is this one. When center of enlargement, is beyond object and image, scale factor is positive. Scale factor is positive. So the scale factor becomes positive when the center is beyond the object and the image. A good example is this one. You may have this as the object, and you may have that as our image. So you can see, if for example, let me say, for example, we have something like this. If this is the object and that is the image, as usual, this is 3, this is 6, this is 5, this is 10, this is 4, and that is 8. Remember, I told you, when you're finding the center of enlargement, you join corresponding point of object and image. So this point of the object corresponds to that point of the image. You join with a ruler, and also this point here, this point here, also this point here correspond to that point here. So you join. So they are meeting somewhere there. So where they are meeting, that is the center of enlargement. Now, because the center is beyond the object and the image, it means the scale factor will be positive. So here scale factor will be distance moved by image over distance moved by object. So distance moved by the image, if I take this as my image 6, the object will be 3. So the answer will be positive 2. Why positive? Because my center is beyond the object and the image. So now, I want you to understand something very, very important here. So, the matrix which represents all enlargement, is this matrix K0, 0K. So this is a matrix which represents all enlargement, where you know that K is scale factor. So where you are aware that K is the scale factor. Now, I want you to note, when I say NB means not this. You must know this. Very, very important. When center of enlargement is origin. You know what I mean? Origin meaning it is passing on 0, 0, or when center is O. The formula we use is this one: matrix times object equals to image. That's the formula to use when the center of enlargement is origin. Then number 2 method you need to remember. You need to remember that when center of enlargement is not origin, meaning it can be 1, something, 0, 0,1 or so forth. As long as the center is not origin, we use this formula: matrix times object minus center plus center equals to image. This formula is only applicable when the center of enlargement is not origin. Now, I want to take one example. For example, I can say point K, 3, -2 is mapped onto point M by an enlargement of scale factor negative 3 through the origin. Calculate coordinates of M. Point K, 3, negative 2 is mapped onto point M by an enlargement of scale factor negative 3 through the origin. Calculate the coordinate of M. So this one is a very simple question. So the first thing you need to know is to have data collection. You must have data. Very important. Point K, 3, negative 2 is mapped. Remember we said in the first segment, the one being mapped, that is the object. So object is point K, 3, negative 2, because it's the one which is being mapped. Onto, that is the image, onto point M. So image is point M. I don't know if you say X, Y. Okay? By an enlargement of scale factor, so the keyword is you are dealing with enlargement. Scale factor K, they have given you negative 3, and they have said through the origin. When they say through the origin, it means center of enlargement is 0, 0. Now remember, since the center is 0, 0, I told you the formula to apply is matrix times object equals to image. Because the center is 0, 0. Since you know you are dealing with enlargement, you can state the matrix of enlargement is K0, 0K. You can master that one. The object being mapped was K, 3, negative 2 should be equal to the image, which is point M. You know what K is? K is negative 3, 0, 0, negative 3. And you multiply now. So this will give you M. So you know M now will be, you know how to multiply row times column. Last times that, negative 9 plus 0 times 2 times negative 2, 0. Also row times column, 0 times 3, 0 plus negative 3 times negative 2, positive 6. So this will be negative 9, 6. So you can say therefore, this implies that M is negative 9, 6. So this is the coordinate of M. Don't leave your answer as a vector. The image and the object are always written in coordinate form. So that's the first scenario you need to understand on that example. Example number 2, you must remember this. I can say triangle, or maybe if I go to triangle, I can say point P, 5, negative 1 is mapped onto point S by an enlargement through by enlargement through 5, 2, means that's the center of enlargement. Find by an enlargement through this whose scale factor is 2. Find the point S. Find the point S. So point P, 5, negative 1 is mapped onto point S by an enlargement through 5, 2, whose scale factor is 2. Find the point of S. So first of all, solution. Remember I've told you, you need to have data. Data collection is important. Point P is mapped. The one being mapped, that is the object. So object P, 5, negative 1, onto point S, that's the image. Onto, that is the image. S, I don't know. It will be X, Y. Through that is the origin. So that is the center. So the center through, that's the center. 5, 2, that's the center of enlargement, whose scale factor is 2. So the scale factor is 2. Now, find the point S. find the point S. Now remember, the center of enlargement is not origin. The center of enlargement is not origin. So, matrix times object minus center plus center gives you image. That is the formula that becomes applicable. Why? Because the center is not origin. Therefore, because the center is not origin, to replace now on the matrix, you know it's K0, 0K, and you put square bracket, or object, that one which has been mapped, 5, -1, minus the center, 5, 2, you close, and don't forget plus the center, 5, 2, which gives you the image. So you know K, the scale factor is 2, so you continue 2, 0, 0, 2, times 5 minus 5, 0, -1 minus 2, -3. Don't forget there is again plus the center, which gives us S, which is the image. So again you multiply row times column. By the easiest way is this one multiply, this one cancel. This times that, 0 plus. This times that, 0. Again row times column. This times that, 0 plus. This times that, -6 plus 5, 2. This gives us S. So 0 plus 0 is 0, 0 plus -6, -6. This is added to 5, 2, which is equal to S. So finally, S will be equal to 0 plus 5, 5, -6 plus 2, -4. And you can say, thus, this implies and is implied by S is 5, -4. So you have calculated the image, which is S. So you can take this if they ask you to plot it on a Cartesian plane, you plot, and so forth. So we want to conclude now. We want to know how can someone identify enlargement, or how can you describe enlargement. So the last part now we are looking at is description of enlargement. Description of enlargement. So we are now describing enlargement. First thing, when you're describing enlargement, number one, give the name. You must tell the examiner that this one is enlargement. Then number two, you must give them the scale factor K. Give them K, which is the scale factor. Number three, you must give them also center of enlargement. Center of enlargement. These are the three important things you need to mention in your description. The name as enlargement, second, the scale factor, and the center of enlargement. Like for example, if you've got something like this, enlargement, you can only identify them using your eyes. You can see some, remember I told you they should have similar shape, but one can be smaller, one can be bigger, like in this scenario. Now you've got 1, 2, 3, 1, 2, 3. So you've got this. You've got that. And then you've got 1, you've got 2, you've got 3. And then this is another thing that you have. 1, 2, 3. So this is also another thing that you have. And then this is triangle A, this is triangle B. So if you look at these two triangles, one is bigger, one is smaller, and they've got the same shape. If you see that behavior where one is bigger, one is smaller, and they've got the same shape, that can be enlargement. So if they say, for example, to say, describe the transformation. Describe the transformation fully mapping triangle A onto triangle B. You know, here by observation, you can tell that's enlargement, that is 1 mark. But now, you need to calculate the scale factor first. So there are 2 methods. The first one, scale factor, can be distance of image from center, can be the first one, over distance of object from center. It can be the first. And you know how to find the center of enlargement? Just join 2 corresponding points. For example, this point here correspond to this point here, so you join them with a ruler. Get it? And also this point here, so it's coming like this. And then this point here correspond to that point, so you can see. So they are meeting here at O. So that is the center of enlargement. So it means the center is O. Then you take your ruler, you measure. Okay, they are saying it maps A onto B. So B is the image, A is the object. So you measure with the ruler from there to that point, you record. Let's say it gives you 8. Again from the center, since you pick this point, it has to be correspond to that point. From there, again to there, you measure, maybe to give you 2. So it's going to be 4 as a scale factor. Then now, since the center is between the object and the image, your answer will be negative. So now you can describe your transformation. So you can say the transformation mapping triangle A onto triangle B is enlargement. That is 1 mark. You tell them the name, can be half mark or 1 mark, is enlargement. Whose scale factor is -4 through origin. So there is a center, there is a scale factor, and there is the name. So that's what makes the description complete. So I know you have enjoyed this lesson. Next time we meet again, we'll talk about shear and stretch. That will complete the segment of transformation. So keep us updated how this program is blessing you. Thank you so much. I believe you have enjoyed the segment of enlargement. We want to hear your call. We want to hear your view. Just on the screen right there is the email address that is displaying and the phone number is displaying. You can write to us, you can contact us. For example, you want to hire us to come and change the face of mathematics at your school or so forth, or you want to do tuitions with us. We are right here in Lusaka, and you can contact us just using those numbers showing on the screen. You will never go wrong. Epignosis Tuition Center is a place to be because we are so much loaded and root in knowledge. Our own knowledge is excellent and very fertile. So I'm looking forward to hear from you, and I know you'll never go wrong. Thank you so much.